Hello everyone! In this video we're going to talk about multiplying polynomials. So last week, remember, we learned about adding and subtracting polynomials. This week we're going to talk about multiplying polynomials, which will be a good intro into our next section, which will be factoring polynomials, which is the opposite of what we're going to be doing this week. So, yeah. And remember that this is really just to practice pattern recognition and number sense, really, especially with this and with factoring. So these are important skills for you. And let's get started. So we're going to talk about how can we multiply two polynomials. And we've got some objectives. I can multiply binomials, I can distribute to all terms, and then I can multiply trinomials. So remember, binomial is 2 terms, trinomial is 3 terms. And I've got this nice meme for you, which you probably don't understand yet because I haven't taught you anything yet. But when we finish the notes, go back to it and see if you understand it. So this says, what do you use when you're multiplying polynomials? Distributive property. So we're going to talk about what that is, which I believe is a term you've heard and learned about, but this will be a good refresher. And we're going to cover some vocab that we covered in the last section as well, just so keep this all fresh in your brain, so that you're familiar with the vocab that we're going to be using. So remember that monomial is a number, a variable, or the product of a number and one or more variables with whole number exponents. So for example, 6 is a monomial. For example, x squared is a monomial. For example, 6 x squared y is a monomial. All one term, not adding or subtracting anything, all being multiplied. Okay, how about a binomial? Well, that's a polynomial with 2 terms. For example, 6 plus x squared. A trinomial? Well, that's just a polynomial with 3 terms. So like 6 plus x squared minus x. We got 3 terms. And a polynomial is a monomial or sum of monomials. So that can be anything. A polynomial is just 6. Polynomial is 6 minus x squared, which is also a binomial. You get the idea here. We've talked about all this before. So let's keep going. Distribution. Okay. So the distributive law says that multiplying a number by a group of numbers added together is the same as doing each multiplication separately. So I'm going to create an example here that we can see with actual numbers here. I'm not going to put any variables in this one. But let's say, all right, let's talk about like Skittles. If I have 3 Skittles, and then you are very kind and you give me 4 Skittles. So I now have 3 plus my original 3 plus your 4 Skittles. Awesome. I now have 7 Skittles, right? And then a kind stranger doubles my Skittles. So then I multiply that sum times 2. Okay, so you can say, well, this is really just 2 times, do what's in the parentheses, 2 times 7, which is 14, right? Or, okay, this distribution law says, or you can distribute this 2 to each term, and you look at the same thing. So this is the same as 2 times 3 plus, apply that 2 to that 4, 2 times 4, and this is, what's 2 times 3? Well, that's 6. What's 2 times 4? Well, that's 8. Hey, we get the same thing. And this is why this law works. So then we'll start to apply this to variables with polynomials as well. So, in the FOIL method, I'll put this up here, but this is just a shortcut for multiplying 2 binomials by finding the sum of the products of the first term, outside term, in terms, and last terms. Which just means you have a binomial, x plus 1, and another one. This has to be 2 binomials. X plus 2. We take the product of the first term, so x times x, which is x squared, plus the sum, the products of the first terms, the outside terms, so that's like x and 2, which you might be able to see this is really just the distributive property, so this is plus 2x. The inner terms, this is 1 and x, plus 1x, and then the last terms, this is 1 and 2. This is plus 1 times 2, which is 2. And we'll talk more about this, and this will make more sense after we talk about distributing polynomials. But FOIL is just a mnemonic for multiplying polynomials. And a mnemonic is just a fancy word for a mental shortcut. So it's just a phrase, FOIL, first, outer, inner, last, to help you remember how to multiply binomials. But it's really no different than just the distribution. That's all it really is. It's nothing fancy, really. It's just distributing. You know, we take this x times both of these terms, and then the 1 times both of those terms. That's just distribution. So let's keep going. We'll talk about this. We'll apply this. So objectives 1 and 2, we're going to multiply binomials using the distributive property. So when we expand, that means we're going to multiply these two products out and get a polynomial as an answer, instead of two different polynomials being multiplied together. So, using the distributive property, this means I can take x times this whole thing and 8 times this whole thing. And by whole thing, I mean this x plus 2 term. So that means I'm going to take x times x plus 2, and I'm going to add 8 times x plus 2. I'm going to distribute that x plus 2 to both the x and the 8. And then we're going to distribute again. So we're going to take x times x and x times 2. We're going to do the same thing with this 8. Let me get rid of this one arrow up here so you can see okay. And this is going to be 8 times x and 8 times 2. Okay, so now x times x, well, that's just x squared. We got 2 x's. X times 2, well, that's just 2x. Plus 8 times x, which is 8x. 8 times 2, which is 16. And now we combine like terms. So this is just an x squared. We got a 2x plus an 8x, which is 10x. Plus 16. And that is our answer. So that is how we expand x plus 8 times x plus 2. Now let's look at this term. So we're going to apply this x to this whole term and this 5 to the whole term. So we're going to take x, or excuse me, the negative 5. Don't forget this is negative here. So we're going to apply a negative 5 to that whole term. So it's going to be x times x plus 1. I'm going to say plus a negative 5. Plus negative 5 times x plus 1. Alright, so now let's distribute. We got x times x and x times 1. So this is x times x is x squared. X times 1 is just 1x, or just x. I'll write the 1. Okay, plus negative 5 times x, which is negative 5x. And then negative 5 times 1, which is a negative 1. Okay, and you might not need to write these parentheses if you're okay with just saying, negative 5 times x, you can just write minus 5x. So I just added a step here, but you might be able to do that in your head, okay? So this is x squared plus 1x minus 5x minus 1. Now I can combine like terms. This is really just x squared, 1x minus 5x, that's a minus 4x minus 1. And that's how we expand polynomials using the distributive property. This whole set of notes is really just 3 different ways of multiplying polynomials, specifically binomials. You see how this is an x squared here? This is degree 2. These are called quadratic polynomials, and they have major applications in projectile motion. So like I mentioned in the other video, like if I throw something, it follows a curve, which follows this form, this x squared form. And that's why we do a lot with binomials, is because quadratics, these x squared items, these x squared polynomials, they have the most application to various phenomena. So that's why we focus a lot of time on binomials. All right, let's keep going here. So this is my personal favorite method. It's just very clear. So, but it's all really the same thing. It's just different ways of representing the same thing. And that's the beauty of math, is there's never just one way to do something. So we're going to multiply binomials using a table. So we're going to find 2x plus 3 times x minus 3. We're going to use this table. So above each box up here, we're going to put a term of one of our binomials, each term of one of the binomials, and then same thing for this row and this row. So we're creating an array. So I'm just going to put the 2x plus 3 on our columns up here, but just know it does not matter what order you do this. You will get the same answer. So I'm going to put the 2x and then the positive 3 over here. And I'll put the x right here and then the negative 3 down here. And I believe I misspoke earlier. I said it doesn't matter the order. I could have put, so I'll just do this real quick here. I could have done x and then a negative 3 over here, and a 2x and the 3 here. As long as you keep your binomials together, you'll be good to go. So no matter which of these tables I use, we'll get the same thing. So I'm just going to go ahead and use the one that I started with. If you want to double check me and use the other one, feel free. And now, each of these boxes are like a product box. So I'm going to take, this box connects this 2x and this x, so I'm going to take 2x times x, which is 2x squared. Okay, I'm going to go right here. This box connects this 3 and this x, so I'm going to take the product of 3 times x, which is 3x. And now this box connects the 2x and the negative 3, so I'm going to take negative 3 times 2x, which is negative 6x. And then this box over here connects the 3 and the negative 3, so I'm going to take 3 times negative 3, which is negative 9. And now, some of you might have learned something like this to multiply large numbers. It's called the lattice method. And this is kind of like that, because now we add each of these boxes together, and this is our answer. So we get 2x squared plus 3x minus 6x minus 9, which equals, we're going to combine some like terms, so 2x squared plus 3x minus 6x is minus 3x minus 9. This is our answer, and that's how you can find a product of two binomials using a table. So if this structure works for you and makes sense to you, you can always use this method, and that's okay. That's just fine. On any sort of assessment, I'm not going to tell you specifically to use a certain method. I will on one of the practices just so you know how to do each of them, but I won't, on any quiz or anything, I won't make you choose which one to use, so you can choose which method works well for you, which one you understand the best. I'm just here to show you lots of different ways to do the same thing so that you can choose what makes sense to you. All right, now we're going to talk about this FOIL guy, which, y'all, this is just distribution. Big secret, I'm blowing it. All you do is, with this, is you just skip one. You just skip one of the steps, and that's all it is. So it's just a little bit of a shortcut. But in doing this, I just want you to know, I want you to make sure that you know this is just distributing. It's the same thing. So FOIL, I'll write this out, is first, outside, inside, last. And these words reference the terms. So like the first terms is this x and this x, so these are the first terms. The outside terms are the terms on the outside, so that's this x and this negative 7. Oops. Inside terms are this 3 and x, they're like the two terms that are inside of this whole product of binomials. And then the last terms will be the last term of each binomial, which is the 3 and this -7. So let's go ahead and do this for this first one. So we're going to multiply the first term. So I'm going to take x times x, which is x squared. Now I'm going to take, okay, I guess I should follow the order O outside. So I'll take this x times the -7. Do you see how I'm really just distributing this x to both the x and the -7? Do you see how this is just the distributive property? So I'm going to take x times -7, which is -7x. And now I'm going to do the same with this 3. I'm going to take this 3 times the x, and then the 3 times the -7. So we're going to take 3 times x, which is 3x, and then 3 times -7, which is -21. So we just distributed this first x to both terms in the second binomial, and then we did the same with the 3. So it's really just distribution, but we skipped one of the steps. It's just a little bit of a shortcut. And now we combine like terms, and we get x squared. See, -7x plus 3x, that's a -4x, -21. And that's our answer. Now this one, we do the same thing. So we take the 2x times the 5x, and then the 2x times the -4. So 2x times 5x, that's 2 times 5, which is 10, and x times x, which is x squared. 2x times -4, that's a -8x. And now this -1 times 5x, which is -5x. And then a -1 times a -4. Two negatives make a positive, so this is plus 4. And then we combine like terms. So this is 10x squared minus 13x, because that's 8x minus, that's -8x minus 5x, that's minus 13x, plus 4. That's our answer for that one. So that is 2x minus 1 times 5x minus 4 is 10x squared minus 13x plus 4. That's how you multiply binomials using FOIL, the FOIL method, but just please just know that this is just the distributive property. Just make sure you take this 2x times both terms in the second binomial, and then the -1 times both terms in the second binomial. You're just distributing the terms. It's nothing really that fancy. Okay. I believe I've got, we've got this example and then one last one. Okay, so we're almost done here. Okay. Now, multiplying binomials and trinomials. You can actually do any of the methods that you saw above that work for you and that makes sense for you. It doesn't matter what method you choose. So, I think the method I'm going to show you is the distributive method, which was the first one that we talked about. But if you like the table method, then try the table method and see if your answer matches mine, and it should. And yeah, so I'm going to distribute this one. So I'm going to take x times this whole polynomial, and then -3 times this whole polynomial. So I'm going to write that out. I'm going to take x times our trinomial over here, which is x squared minus 4x minus 4. Okay. And then we got a minus 3 times this whole trinomial again. X squared minus 4x minus 4. And now we're going to distribute. So I'm going to erase all these lines. So I'm going to multiply this x times each individual term inside of these parentheses. So I'm going to take x times x squared, which is x cubed. Let's see, x times -4x, that's -4x squared, because we got 2 x's now. And now x times -4, that's just a minus 4x. Okay, now I'm going to distribute this negative 3 to each term. So I'll just do this one at a time this time. So negative 3 times x squared, that's negative 3x squared. Take this negative 3 times this negative 4x, that's negative 3 times negative 4, that's a positive 12x. And this negative 3 times this negative 4, again, that's a positive 12. Whew, all right. Now we combine like terms. So let's see. How many x cubed terms do I have? I only have the one. Okay, so I'll write x cubed right here. Now I'm going to go ahead and cross this off, just so I know that I've accounted for it. And now our x squared terms. We have one right here and one right here. That's a negative 4x squared minus 3x squared. So that means we have a total of negative 7x squared. So I've accounted for that one. I got that one. Let's do our x terms next. So we got a negative 4 and a positive 12. So negative 4 plus 12 is really like 12 minus 4, so that's a positive 8x. And cross those off, and we're left with just a positive 12 over here. And now we can't combine any of these terms anymore, so that is our answer. And that is how you multiply a trinomial and a binomial. So first, we distribute the first term of the binomial to the whole trinomial, and then the second term of the binomial to the whole trinomial. And then we distributed this x to each term, and the negative 3 to each term, and then we combined like terms. So we kind of distribute twice and then combine like terms. And now let's do this last problem here. All right, applying polynomials. So trapezoids are everywhere, y'all. This is the trapezoid. The definition of trapezoid, it just has one pair of parallel sides. And that's all a trapezoid is. So this purple piece of stained glass has a trapezoidal shape. So it is in the shape of a trapezoid. So this length right here is 3x minus 6. The length here is x. And this length of this height, this altitude, is x minus 1. And now you might say, okay, why would something ever be defined in terms of x? And this is actually really, really common when you're talking about scaling items. So if I want some of these tiles to be like 2 inches on this side, but then some like 4 inches, which means this x would be switched between being 2 and 4, but you want all the proportions to stay the same, this is when stuff like this comes in handy here. So we're going to write a polynomial that represents the area of the piece of glass. And you might say, oh, Miss Anton, I learned area forever ago. I can't remember. And y'all, if you can't remember a formula, you want to know what you can do? Big secret. You can just Google it. That's what I'm going to do. Even though I am the math teacher. I do have this one memorized, but that's just kind of by chance. So, if you didn't know this, just Google it. The area of a trapezoid is... how should I say this? Maybe I can draw a separate picture. The general area of a trapezoid... Come on. Draw me a picture. Come on, friend. Okay, I'll just draw it down here. A trapezoid, if this is A, and this one is B, and then its height is, let's say it's H, is A plus B over 2 times H. So I'll put these in parentheses, times H. Okay, so let's write a polynomial that represents the area of the piece of glass. So our area equals A plus B. Actually, I'm not going to write it like that. Can I write this a different way? Is that okay with you? Just for the sake of making this easy for us. I'm going to write this as 1/2 times A plus B times the height. I'm going to write this formula like that, which is the same thing as what I wrote before. I just pulled out that 1/2 so that this will be easier for us to deal with. So our area is going to be 1/2 times A, which will be 3x minus 6, plus this b, which is just x, times the height, which is x minus 1. I'm going to go ahead and delete my trapezoid down here. Okay. So I'm actually going to go ahead and simplify this. We're going to go ahead and actually multiply this out. And let's see, we're going to combine some like terms. So you see we have 3x and an x. This becomes 4x minus 6. My brain was getting a little bit ahead of me. 4x minus 6 times x minus 1. Okay, now we do have a binomial. So I'm going to go ahead and use FOIL for this one, just for the sake of practicing FOIL. So remember, we're taking 1/2 times this whole thing. So I'm going to take 4x times x, which is 4x squared. 4x times a negative 1, which is minus 1 times 4x, which is minus 4x. Negative 6 times x, which is minus 6x. And minus 6 times minus 1, which is plus 6. Okay, and now this equals 1/2, oh dear, 4x squared. I'm out of room. Negative 4x minus 6x, that is minus 10x plus 6. Okay, y'all, last thing. I'm going to delete some stuff up here because I ran out of room. So I'm going to go up here, and y'all, we can distribute this negative to each term. So I'm going to distribute this negative to this 4x squared. I'm just going to delete everything up until this point. Alright, so just give me a second here. Just so I have space here. Okay, I'm going to go ahead and distribute this 1/2 to each term. So 1/2 times 4x squared. So 1/2 of 4 is 2. So this is really 2x squared minus, let's see, half of 10x. So, whoops, that's going to be minus 5x. And then half of 6 is 3, plus 3. So that means this is the area of this trapezoid is represented by this polynomial. So this is our answer to part A. Now part B, if the shorter base is 7, what's the area? Well, hey class, the shorter base, see how the shorter base is just x? So they're really saying if x is 7, what's the area? Well, let's plug in x equals 7. So this is going to be 2 times 7 squared minus 5 times 7, because we replace each x with 7, plus 3 equals the area. Okay. 7 squared is 49. 49 times 2 is 98. Minus 5 times 7, which is 35, plus 3 equals the area. Let's see, what's 100 minus 35? 65. Plus 3, plus 1. So this will be 66. So the area is 66. What's our unit? Square inches. Alright, so we used all kinds of different skills to practice that one. We used Google to find the formula for the area of a trapezoid, and we practiced multiplying binomials, and then we practiced plugging in a variable for an equation and solving for it. So that's it for this video. Please email me or come talk to me. Ask me to call you in for when if you have any questions or need any help with multiplying polynomials.